Hi, my name is Christian, and welcome to Brilliant Design. We're going to do another round of CNC stuff. I have my very helper cat here who is trying to knock everything over. And what we're doing is we're making some aircraft parts, and I'll show you what they look like. Here's what the basic part looks like. You can see it has a bearing down in the center, and it has 3 plates. And the plates have center section plates in them, and then there's holes drilled all the way through them, and this is serving a purpose of an aileron bell crank. And so what I've done is I've taken that and made a DXF file of the flat lay of the part, and if you open the individual part, there's one of the parts there. You can see it's just a flat plate. They specified it's 156 thousandths, and the nearest I come up with is 160 thousandths, and that's in 2 80,000th sheets of 6061 T6. So the other part is like this, and you can see what that looks like. It has a bend on it. There's 2 of those parts. So if I go in there on that part, you can see it's got a bend to it. And one of the options I'm allowed here, because I've drawn it as a sheet metal part with very specific bends, is I can take and flatten the part like that. And it has the, you can see on the top there, it's got the specific bend points in it. So if I go in there and bend it back again, that's what the part looks like. Okay, so now I've actually cut some of these out, and so what I'm going to do is I'm going to show you what those parts look like. And there's a part that I've cut, but it doesn't have the bend on the end yet. And I've already drilled the holes. I'm going to show you how I did that. I've created some of these other plates already. Here's a stack of them here, and it's important to have all the rivet holes, and the plasma cutter won't cut the rivet holes very specifically. So what I'm doing is I'm putting little divots everywhere there's a rivet hole, and then I'm hand drilling them out, and I'll show you how to do it. And you can see that there's a lot of dross on these. See on the back side there's quite a bit of dross up here around the edge. And so for each of these I need 4 plates, and so I've already got 2 plates on there. There's the 2 extra plates that I need to clean up and drill. I'll show you how to do that. And then that's what it looks like assembled. And it has yet to be bent, and it's being held together with Clecos. So I'll take you into the shop and show you how I actually cut those out in PlasmaCAM. Okay, so now I'm getting ready to cut out those center sections. And first thing I'll do is I'll show you close up on the screen here which one I'm cutting out. And so it'll be this one right here and this one right here. And what I'm going to do is I'm going to draw a box around it so I can see what I'm doing up close. And I've already converted them into cut paths, and if you look really close right here, you can see what I've done is you can see my cut line that I've offset, the path, the cut path, and you can see the circles. And what I do, I'll show you how I cut those circles out, but I'm going to go back to the previous views so you can see. And I'm ready to cut here. Okay, I've imported all these parts in on PlasmaCAM, which is what we're looking at here right now. And I'm going to zoom in on the actual sheet, and what I've done is I've drawn the sheet the size it is. I've measured it carefully, and here it is sitting on the table. So you can see I use steel to hold it down flat, and you can see all the ring parts that I've cut out, and you can see I've already cut out 2 of the oblong end parts with the arms, and I've already pre-dimpled these, and you can see that there's some quite a bit of dross, but you can also see that I can pick that dross off, and I'm left with a nice little dimple at the where the location is. And so then I can use that to take and drill with the drill press. Okay, We're going to move our cable out here. I'm going to select a point. I'm going to show you how we make these divots in the material. I don't convert the little holes. Actually, I do convert them, but then I just delete them. And the purpose behind that is that way I'm left with just a raw circle of whatever size the hole is supposed to be. Doesn't really matter because I use the centering snap function. And so what I'm going to do is I'm going to select one of these top holes right up over here, and then I'm going to tell it to move to that point and select the center snap for that hole. And as the torch moves out to that location, then what I do is I put it in Z-jog mode so I can go up and down with the head. I have a little piece of aluminum here, I'm not sure, I think it's 1/8 of an inch thick. And I put that down on the table, and then I jog the torch down until it just touches it. In fact, I pinch it a little bit, and then I back it off just a couple thousandths, just enough so I can slide the little hunk of aluminum off. And that gives me good spacing. Okay, then the next thing I do is instead of the 45 amps that I'm normally running it at, I turn the torch down to 20 amps. And now that I have my height set good, I do test. And I just hit it for just a second, just long enough for it to divot the material. And then I select the next hole, center snap to it, and I move over to it, and then I hit test. Make sure it actually makes a divot. And apparently I've got air problems, so stand by on that. Okay, so I hit test on that. You hear the compressor come on. Then I'll move over to my next location with the center snap. And I just do that for all 20 holes. Okay, so when I do this, I don't know if you can see on the screen, but basically what I do is I start at the top hole at 12 o'clock, and then I move down to the 1 o'clock position, so I go V, which is move to. I middle click the mouse roller wheel, and I say center snap, and then I move to it, and I never click on the center to make sure that it actually goes to the center. Then I hit test. Then I move to the next one, V, center snap, boom, make sure it's on the center, hit test. V, center snap, and it doesn't take too long to do it. V, center snap, and if you zoom in, it actually keeps track of the location of the cursor of the torch location on the screen, and you can see by the little yellow mark. And all you do is just hold it down for a split second. And I'll show you what that's actually looking like when it does it. So here comes V, center snap, move to it, and then hit test. Okay, then I check all my holes to make sure they're all good, and they are. So the next thing I do is I zoom out a little bit on the screen, and then I pick the series of holes I want to do, and I cut them. And, oops, I forgot I had it still set on 20 amps. It needs to be set on 45 amps. Okay, so we'll try that again. I gotta wait for the compressor to build up air again because it was a little low. So, okay, so here goes a real cut on the lower kind of rectangular hole. The upper hole, and now I'm going to cut out the full pattern. And I get ready to catch it. So there's the finished product. And then all I have to do is do those steps to it. So that's a quick lesson on how to create very accurate CNC parts, cleaning them up, prepping the holes, drilling the holes, and finishing the holes and cleaning up the part. And I'll show you what it looks like when it gets done. Okay, since it takes both hands to do control on this, I've already selected them. You can see, I don't know if you can see it, but they've turned green. And what I'm going to do is I'm going to do a cut preview so I can see the order in which it cuts. So the first thing it says, how fast you want to go. I say, oh yeah, whatever. And then, see, it does the bottom one, then the center circle, and then it does the outline. So I'm going to commit to that, and I'm going to tell it to get ready to cut. And I'm going to say cut, and we'll watch the machine work. And then I catch that part. And so what I'm going to do is jog it out of the way. So I lift it up, and I bring it forward. I bring it forward out of the way, and there's my cut part. So as you can see, I've already got a couple of these cut. There's the one I just cut. It's a little bit warm, but you can still touch it. And you can see the dimpled holes in it. So then what I'm going to do is take this part. This is another part that I just cut out. I'm going to bring it over here to the drill press, and I'm already checked up with a 1/4 inch drill bit. So I'm going to fire that. Up, and I'm going to have to set the camera down. Okay, so what I'm going to do is I'm going to take this dross and just manually break it off by hand, because the Hypertherm PowerMax 65 does a really good job of just melting it and cutting it. And I don't know if you can see that edge quality, but it's really nice. I had to slow it down from what the book said. I'm running at 100 inches per minute, which is quite a bit slower, about half of what the book says. But anyway, once I get all this dross broken off, which just, you know, fractures off by hand, then what I do is I take the knife blade and I just run it like that and just break whatever is left off, and it kind of gives a nice camfer to the edge too. And I just do that all the way along, and on the center hole, I have to kind of be a little careful when I do it, but you can kind of see how that works. Feel free to fast forward through this part, but don't go too far forward, because I'll have more handy tips and tricks as I go. Anyway, so after I get that all cleaned up a little so it'll lay fairly flat, then what I do is I take it over to the drill press, and actually I got to do this side a little bit too. This side, the cutting side, comes out with a nice flake that all you have to do is just hit a little bit and it comes right off. It's not even attached at all. It's just flash from the aluminum getting hot and touching the colder aluminum on the top side, and that's pretty much how that looks. Okay, so here's how the back side looks, and here's how the front side looks. You can see that there's a lot of dross where the little targets are. But anyway, what we're going to do is take this over here. I got the drill press set up, and we're going to swap it out from the 1/4-inch bit to the 1/8-inch bit. We're drilling them at 1/8 of an inch, and the actual size you're supposed to drill it is a number 40, I think, or number 30, which is a 128 thousandths. Okay, so now our drill's running, and you can see I've got 8 holes around the edge, and I don't know how many there are there, but basically what I do is make sure this is flat so my piece can sit on it flat. Okay, I'm ready to drill here, so I'll turn on the drill press. So basically what I do is I bring it up until the bit is floating against the divot, not laying on the bottom part, and then I bring it down until the bottom part is just touching it, and I let it float around a little bit. You can see it's wobbling some, and that's fine because that allows the bit to center on where that divot is from the CNC. And then I just do that for each hole. I bring it down, and turning this fairly slowly because I was cutting steel earlier on it, and it'll cut the aluminum just fine, not quite as fast like this. And so you just feed it through, and this lower surface gives you a nice perpendicular to the drill bit to sit on. You can see how that dross broke off right there. So the key part is not holding your material too tightly. Yeah, I had some aluminum in my mouth. Anyway, just let it float, and then that way it can kind of find its own center, and it helps with the accuracy as you're drilling through there based on the divots that you've made with the CNC. And you can see that dross broke off. I have 20 holes to drill here, actually 20 plus 1, because I have that top hole that needs to be drilled out to a 1/4-inch hole. And I'm drilling these with an 1/8-inch bit, and the reason for that is the actual size that they'll wind up being is 128 thousandths, which is a number 30 drill bit, and that is good because once you get all 7 plates lined up, you can ream them. It's got to keep the surface brushed off. You can ream them, and even if there's some misalignment by a few thousandths, that'll clean up the diameter of the hole so that all the holes are basically the same size. Anyway, I'm just going through each one of these. I don't know if they're going to use all the rivet holes for the bearing. I think I would suggest that that would be a good idea since this is a control part for an aileron. But let it float and wobble until it starts to dig in, and then I push down hard, and you can see the nice turns coming off. It's important to have good sharp drill bits when you're doing this so you get a nice cut. Drill bit sharpening is a lost art. Most people just break them and go down and buy new ones, but I have a drill doctor and I highly recommend that. Works really good if you know how to use it. and then got one hole left to go. Actually, I got 3 holes left to go because I got ones on the other side there that I missed. And just those little flakes of dross are like thin like foil. They just break off. So that's given me my nice 1/8" holes. Nice and perpendicular to the material. That way, because if you don't make them perpendicular, then they... Now what I got to do is clean them up with the drill bit. Okay, so I got the drill press running, and what I do is I take and I bring it down till it's just touching the metal, and you can see it's not actually resting on the piece below. And then I bring it down, and it's already sort of pre-dimpled it now, and then I start putting pressure on it, let it lay where it will, and that gives me a nice drill right on center in that hole, and it's pretty much laying flat. Normally I clean the dross off the back side, but that gives me a nice centered hole, and you can see the dross breaks off pretty easily. I can fracture this off, and then I use a knife to just slide the blade along and clean it up. And so I get a nice sharp edge there. Okay, anyway, what I'm using here is just a hand drill with a centering drill, not a regular drill bit. It's actually a machine tool, and it has a 120 thousandths tip on it. And since my holes are 1/8", then what I do is I basically just take and run it in there just a little, knock some of that edge off so it's not, gets rid of the dross and the drill flash. And when you're done, you can feel those holes. And I wish I could zoom in a little better, because then you could see the results. But I get down there and I look at it close, and it doesn't take any extra material off. It just makes the edge of the hole nice and clean and smooth. Okay, well, I know there's been some cuts in this video because I had to do it in several different takes, but hopefully you learned something, and I'll show you what the finished product looks like. It looks like this. And thanks for tuning in, and I'll see if I can make some other interesting videos for you. Thanks. Bye-bye.